told you that I kind of split up this week because we're going to have lots of different rules. So on Monday, we had the rules with when you multiply, you keep the base and you add your exponents. And yesterday, when you raise a power to a power, you keep your base and you multiply those two. Okay? Well, today, this is not the right one. Today, we're going to deal with the division property. Okay? I'm going to skip the 2 to the 7th one. I'm going to go over here to the right-hand side here. T to the 12th divided by T to the 9th. If I wrote T to the 12th out, what would that look like? Okay, 12 times, right? Okay. And T to the 9th is going to be 9 times, right? In a fraction, when you have a number, or in this case a variable, in the numerator and the denominator, what happens? They can cancel. Technically, they become ones, right? But anything times 1 is itself. So this T and this T cancel. And this T and this T and this T and this T and this one and these and these and these and these. What are you left with? T to the 3rd. So in division, we're going to keep the base and subtract. Keep the base. Subtract the exponents. Now I'm going to give you a hint. You have to take the top minus the bottom. So like up above 12 minus 9 gave us 3. You have to take the top minus the bottom. Just like with multiplication, we want to put things together that have the same base. In multiplication, we put them in their own parentheses. With division, I'm going to put them in their own little fractions. Okay, so if we just break down simplifying here, I'm going to separate my G's and my H's. So G to the 3rd divided by G in its own fraction. H to the 5th divided by H squared in its own fraction. So in the first fraction, what's my base? G, and I'm going to subtract my exponents. What are my 2 exponents I'm going to subtract? 3 minus 1. What's my second base? And what are my exponents? 5 minus 2. So my final answer is G to the 2nd, H to the 3rd. Try KMP on your own. Try KMP problem on your own. So I end up with K to the 2nd, M to the, and P to the 0. What did we learn last week? Anything to the 0 power is, here's why. Remember when you asked me why? Why, Miss Hoff? That doesn't make any sense. Right here, what's going to happen? Up above, we said they would cancel, right? This P cancels this P, really turning them to 1 over 1, which is 1. That's why anything to the 0 power is 1. So you don't want to write P to the 0. Technically, that is not simplified as far as it can go. This actually equals a 1, so your final answer is just K squared times M to the 7th. Make a little bit more sense after we talk about that 0 piece. Okay, another rule today is, what if I have a fraction with a power on the outside? Technically, 3/4 to the 3rd means that everything in that parenthesis is repeated 3 times. So it'd be 3/4 times 3/4 times 3/4. Or in other words, really that's 3 to the 3rd and 4 to the 3rd. So if you have a fraction inside the parentheses with a power on the outside, that power belongs to both the numerator and the denominator. Oh, man. Okay, so C divided by D to the fourth really could be rewritten as...
Wait, is that our final answer?
Yeah, for right now, that's what we're going to talk about. So C divided by D to the fourth would end up being C to the fourth divided by D to the fourth.
That's it?
Yep. Okay. 3 to the fifth divided by 3 to the fifth. Keep your base. What's your base? 3. Take your top exponent minus your bottom. What are your two exponents? 5 minus 5 is 0. 3 to the 0. So your answer ends up being 1. No, you type 27 in. Why would I give you an answer that's not the answer?
No, normally we have an exponent.
But why is 3 to the 0 1?
Because if you add a 3, 1, 3, 1, 2 is cancel out 1 over 1 is 1.
So why is our answer 1? Exactly what you just explained to me. All right, so let's put everything together here. Exponent on the outside. That 2 on the outside has to go to absolutely everything in the numerator and absolutely everything in the denominator. So I end up with 3 squared, p to the third squared, and 7 squared. Now, 3 and 7 are your coefficients, right? Okay, so 3 squared we actually want to calculate. 3 times 3 is 9. On your p, keep your base. What's your base? And what are you going to do to those exponents? Multiply 3 times 2. And then 7 squared is 49. So what is 3 times 2? 6. Now, you should always check if you can simplify, or is there anything that goes into 9 and 49? The only thing that goes into 9 is 3, and the only thing that goes into 49 is 7. And there's no other p, so that's your final answer. Do the one on the right on your own. I got 4y to the fourth divided by 9z to the sixth. Good? Yes? No? Yes? Okay. Continuing on, mixing everything together that we know. Negative 4n squared q to the fifth r squared divided by 9n to the third q squared r, all to the 0 power. Where do you want to start? What's that? The whole thing turns into 1. Not a negative 1, not a 1p, not a 1q. It is 1 because everything inside here gets the 0 power, and absolutely anything to the 0 power is 1. You should all thank Caden that we didn't have to go through the work of that before I said it was 1, right?
Okay.
Is it different on this one? No. The answer is still 1? No. What part is 1? Y to the 0 can cancel and become just a singular 1, where then you really have x to the fifth divided by x to the third. Now what do I do? Subtract. Keep your base x. 5 minus 3 is 2. So your answer is actually x squared. So do know the difference. Caden's absolutely right. That 0 power technically would have had to share to absolutely everything, meaning everything would have turned to a 1. Versus this one, only the y is to the 0 power. Do you understand the difference between those two? Perfect. All right, I got another curveball for you. C squared divided by c to the 5th. Keep your base. What's your base? And what are you going to subtract? 2 minus 5, which really gives you -3. I will tell you, negative exponents are not simplified. They occur, but you have to simplify them. Whenever you divide, this ends up in the numerator. Technically, everybody up above was in the numerator as well. It's like a whole number. You don't necessarily write it over 1, right? But we cannot leave this as a negative exponent. To get rid of the negative exponent, you take the negative exponent and its base, and you drag it across that fraction bar. Meaning, if it's negative and in the numerator, it needs to go to the denominator. If it's negative in the denominator, it needs to go to the numerator. Once you drag it across there, your base is still c, but your exponent becomes positive. Technically, what is the coefficient of c? That is what is left behind in the numerator. The 1 doesn't have a problem. Just the c had a negative exponent. So as you're dividing today, you may end up with a negative exponent. It doesn't mean you're wrong, but it means that you are not done yet. Okay, so now you're also going to deal with negative exponents today. Oh, geez. To resolve the negative exponents, move the base to the opposite location of the fraction, and this will make the exponent positive. All right. N to the -5th, p to the 4th, r to the -2nd. There's a couple different ways you can go about this. I go about it as, I know I have division, so I'm going to separate each letter off into its own parenthesis. What's the problem with that? There's only one of each letter, so there's nothing that we're actually going to divide here. Well, why would Miss Hoff give you this problem then? Negative exponents. Okay, so n to the -5th, that base and exponent needs to go down to the denominator. P to the 4th, there's nothing wrong with him. Leave him alone. But r to the -2nd needs to switch locations. So now, what's in your numerator? P to the 4th, r to the +2. What's in your denominator? N to the 5th. Now, if there were things that we could actually divide, I would divide them before I moved them. But in this case, none of them had the same base, so it would not have done us any good. All right, what do we have next? Let's do this one. Go to the right. 5 r to the -3rd t to the 4th divided by -20 r squared t to the 7th u to the -5th. So let's separate this off into separate little fractions, taking our coefficients on their own. So 5 divided by -20. And then base r to the -3rd and r squared. Base t to the 4th and t to the 7th. And then the way I usually do this is I put a 1 up here and then u to the -5th. So I haven't moved anything, I've just separated everything out. Follow me so far? Okay. 5 divided by -20 is not a whole number, but you can reduce, yes? What divides into both? A 5. 5 divides into 5 and turns it into a 5 divides into -20 and turns it into a, no, that 4 is negative. Do I have to move that? It's a coefficient. It's fine. Keep your base. What's your base here? Actually, let's do it this way. When I divide these all, they're going to end up in the numerator, right? So I keep my base r. What's my top exponent? Negative 3 minus the bottom exponent, which is 2. What's my next base? T. Top exponent, 4 minus the bottom exponent, 7. And then I'm just going to leave u to the negative 5th down there because there's nothing to actually divide with it. Follow what I did in all those steps? Okay. So now let's simplify this. Negative 3 minus 2. Negative 5. T, 4 minus 7. Negative 3. There's a 1 in front of it. On the bottom, I have a 4 and a u to the negative 5th. Negative 4. You're absolutely correct. I was just making sure you guys are paying attention. Can I walk away from this? Okay, now I always call this the staying or going game. Now you have to decide if it's staying or going. Is R staying or going? Going. It has a negative exponent. This guy needs to go down. T, staying or going? Going. The 1 and the negative 4 are going to stay because they're our coefficients. How about u to the negative 5th in the bottom? It's going as well. Okay, so what's left in the numerator then? A 1, u to the positive 5th. In the denominator, negative 4, r to the positive 5, t to the 3rd. Double check. Is there anything I can combine? Done. Now, that is not the only way to do it. Some people want to get rid of the negative exponents right away, and there's nothing wrong with that. They move things before they divide, which is fine, but I will still caution you, sometimes you still end up with a negative exponent that you have to move anyway. Jackson.
So, like, when we were at fractions, like, when we're not doing this, we normally put that, if we have like a 1 over negative 4, we put the negative side on the fraction.
You could technically. You could put it in the top, you could put it out front, as long as there's only one of them, it's all still fine. Yep. Do you want me to show you another way that some people do it? On the next one, do it a different way. It's the same, it just sometimes one way makes more sense to people than the others. So sometimes what people do is before they do any dividing, they just decide, like, should that base stay or do I need to move it to make it positive? So I know that my 2 and my 10 are going to stay where they are because they're my coefficient. A squared in the numerator, staying or going? Staying. It's positive. B to the 3rd, staying or going? Staying. C to the negative 5th, going. So I'm going to go write that down in the bottom now. Now in our denominator, a to the negative 3rd, going up to the top. B to the negative 1st, going up to the top. C to the negative 4th, going, whoops, that should not be a negative 1 anymore, should it? A 1, going to the top. Now, technically, all you've done is rid of your negative exponents. When you have a fraction, you want to make sure that you combine everything in the numerator that you can and everything in the denominator that you can before you divide. Okay, so this is like on Monday when we would regroup things. In the numerator, my 2 is going to be out front, but I can regroup my a's, yes? A squared times a to the 3rd will go together. And then your b's, b cubed times b to the 1st. And then we just need to drag along c to the 4th, and in the denominator, c to the 5th. Everybody following what I'm doing here? When I multiply, what do I do to those exponents? I add them. So really, I'm going to take 2 plus 3, 3 plus 1. So I really would end up with 2a to the 5th, b to the c to the divided by 10c to the 5th. What sucks about this is it feels like we've done a ton of work and we're not done. So now we have to separate things off, yes? So my coefficients 2 and 10 are going to be together. A to the 5th doesn't have anything in the denominator, so I'm going to put a 1. B to the 4th doesn't have anything in the denominator, so I'm going to put a 1. And then I have c to the 4th divided by c to the 5th. What goes into 2 and 10? 2, so 2 would become a 10 would become a 5. A and B, they're the only bases of A and B, so nothing's going to change here. C, I'm going to take the top minus the bottom. Yes? So now I'm at a place where I have a 1, A to the 5th, B to the 4th, C to the negative 1st, all over 5. Now, why is C to the negative 1 in the numerator? Whenever you divide, the answer always goes in the numerator. Can I walk away from this problem, though? No, why not? Yeah, I got to make that C really go back down here, right? So my final answer, thank God, 1, A to the 5th, B to the 4th, divided by 5, C to the 1st. Now, technically on this C, do you have to have a 1? No. Now, this is not wrong, but what I'm going to tell you is I would not worry about negative exponents until the very end. Does that make sense? I feel like that was way more work than the one we did before it. Agreed? Because you move things, and then we still had to end up moving things. All right. I think there's one more on here, yes? Try this one on your own. I would encourage you to separate it off and move your negatives at the end. So I'm going to caution you right here. When I grouped everything, 32 divided by 4 is 8. I keep my base of A, negative 8 minus 3. Base of B, 3 minus 5. Base of C, be careful here, negative 4 minus a negative 2. Do you understand why? You always subtract, and the bottom one ends up being a negative. So I really have 8A to the negative 11th, B to the negative 2nd. Now here I'm going to add C to the negative 2nd. Now technically this is all over 1. Now when you play the standard going game, what happens? They all go except the 8. The 8 does not. So you have 8 divided by A to the 11th, B squared, C squared. So negatives give you a different ball game, but if you notice today, you're incorporating all the rules you have. Go to work.